Let's see how can we connect two fabrics together. So you might want to, for instance, communicate two fabric sites that you have in different campus. So this is known as fabric site, and this is another fabric site, and you want to communicate them. And when you have several fabric sites, you are actually creating something that is known as a fabric domain. And you have two options here. You can communicate these two fabric sites using a new fabric site that you are going to build only to communicate these two fabric sites, and we are going to call that a fabric transit, or an Sdaccess transit, or SD transit. So this is a fabric network that has its own control plane nodes, and this is one way of doing it. This has several advantages because this SD transit network is going to keep scalable group tag information and VNID information natively. And the other option you have is communicating these two fabric sites using a traditional wide area network connection. So in this case, we would be using a native IP network that is not, also known as an IP-based transit. So this has the advantage that you can use any known wide area connection technology in order to achieve this. But the disadvantage is that it is harder to maintain scalable group tags BNIDs because natively the IP-based traditional solutions are unaware of the existence of scalable group tags and BNIDs. So this is a challenge, being able to transmit these scalable group tags and BNIDs across this wide area connection. This IP-based transit solution has two methods, the one box method and the two box method that we are going to see later on. So let's go to the first option, that is the SD transit solution. With the SD transit solution, you will be connecting your border nodes, for instance, back to back using an Ethernet connection. This is a way of showing it for clarity. I am not showing redundancy or high availability for the sake of just explaining how this works. So we'll have an Ethernet connection that must support jumbo frame, and it should provide you with 100 milliseconds of latency end to end, with a maximum allowable latency of 200 milliseconds. And you are going to run ISIS here. You can also run BGP, but it is not recommended, so you are better off running ISIS in order to share your loopbacks IP addresses that exist at each site of your fabric sites. So this is the best solution. It involves a little bit more of work because you will need control nodes, because this particular transit network is an Sdaccess network, and an Sdaccess network, it will need its control nodes. So you will need an extra pair of control nodes for this particular transit network. I am showing these control nodes connected to the border nodes just for clarity, but these control plane nodes that belong to the transit can be installed on your shared services block. So you can install here your control plane nodes, your transit control plane nodes in another part of your network, transit control plane nodes. And you can even install them on virtual solutions, use as CSR 1000V. So this has the advantage that the scalable group tags and BNIDs information can travel across the wide area connection. So, given we are going to use VXLAN tunnels end-to-end, the scalable group tag information and the VNID information will be transported end-to-end. So, for instance, if I connect here a device that wants to print into a printer that lives here in the other fabric site, then a VXLAN tunnel will be built into this border node, and then after receiving this VXLAN packet, this border node will create another VXLAN tunnel to the border node in the other side, and then the border node on the other side will create another VXLAN tunnel to the destination device. So we are going to use VXLAN end-to-end, and remember that in the headers that exist within a VXLAN tunnel, we can carry scalable group tags and BNIDs, so we can carry our scalable group tags and BNIDs across all our fabric sites. This is known as unified policy, and it is the advantage of using an SD transit connection between sites. So let's examine how the IP-based transit works. Remember that in this case, we're going to use a traditional IP network as our wide area connection. And we can have an SD-WAN, we can have a Cisco I-WAN, we can have a DMVPN solution, we can create GRE or IPsec tunnels, or we can have a carrier let us communicate these two sites through multi-protocol BGP. So it is easy to connect these two sites, but the downside is, or the question here is, how I'm going to maintain macro segmentation information and micro segmentation information. How I'm going to carry scalable group tags from one end to the other end, since we are using a traditional IP network. Remember that traditional IP networks don't know what are scalable group tags. And the other question is how I'm going to carry BNID information for my macro segmentation. How I'm going to carry BNIDs. So the solution is basically, for scalable group tags, I'm going to set up inline tagging or the SPX protocol. That are solutions that are clearly explained by the Cisco Trust Sec solution. And in order to maintain the BNIDs or macro segmentations, I am going to create BRFs. I have to make sure that these BRFs exist end-to-end through the wide area connection, so I can maintain my BNIDs information. So let's see how we are going to accomplish this. We have two options: the one-box method or the two-box method for keeping macro segmentation information. For micro segmentation, for scalable group tags, we're going to use always inline tagging or the SPX protocol. But let's examine how macro segmentation can be kept across a transit IP network. So with the one box approach, I am going to use only one box here, which is my border node, one box here, which is my border node, and this means that I'm going to have to work a lot with my border nodes. I will have to configure my border nodes heavily in order to have this approach. The border node, it is going to do almost everything, and I will need to have a routing platform for my border node. Remember that when choosing your devices, in order to become fabric devices, you can have layer 3 switches, or you can have routers. In this case, in order for this to work, you have to choose a router-based platform for your border node. Do not use a layer 3 switch, because layer 3 switches usually don't have support for DMVPNs or IPsec solutions. So for instance, if we had um, two um, two virtual networks at each site, then if I went through the one box approach, at the border node, I will create, for instance, one IPsec tunnel, and this IPsec will be used in order to communicate these virtual networks together, or to each other. And then I will have to create another IPsec tunnel between border nodes in order to let the VNI number 1 on one side to communicate to VNI number 1 on the other side. So I could do the same with the DMVPN approach. For instance, if I had two DMVPNs, two VNIDs, for instance, red VNID on both sides, and an orange VNID on both sides as well. Then, for instance, in this border node here, I could choose this border node as the hub for my DMVPN solution, and I will create a DMVPN with this other border node. And this particular DMVPN will serve to communicate these orange virtual network IDs. And then in order to communicate the red VNIDs, I will have to create another DMVPN domain. So I could choose this border node as the hub for the DMVPN domain, and this other border node as the spoke. And then I will create another DMVPN domain that will help me communicate these red virtual networks together. So when using the one box approach, I have to configure heavily the border node. It has to be a router, and I can go for DMVPN solutions or IPsec solution in order to communicate virtual networks together. Now, the other approach is having a two-box approach. So I'm going to have my border node here that it is not going to perform too many functions. This border node here can be a layer 3 switch or a router. So I can use a layer 3 switch or a router as my border node, and that will be my first box. The second box is an extra router that I'm going to need, and most of the configuration is going to go into this second box. So that is why we are calling this a two-box solution. The border node is one box, and the external router is a second box. In this case, I'm going to set up .1q communication here between my border node and the router, .1q, and I'm going to communicate this border node with this other router with the BRF Lite, just as we regularly do between the border node and the fusion router, the exact same configuration. And then in order to do the magic of communicating VNIDs, I'm going to rely on several options, and these options will be configured in this router. I'm not going to overload the border node with a lot of configuration. The border node is not really doing a lot of stuff here. The device in charge of doing the magic will be this secondary device of router. So let's examine how this can work. For instance, if I had two BNIDs, BNID red and BNID orange, I could create, for instance, between these two routers, one GRE tunnel that will serve to communicate these orange BNIDs and a separate GRE tunnel in order to be able to communicate these to these other red BNIDs to each other. So that is one way of doing it. I could go for DMVPN or IPsec. That will be the same. For instance, I had one BNID here, red, another BNID red, and I had I could have an orange BNID, and then I could select this router to be the hub and this to be the spoke, and I could set up DMVPN here. With an example of 2 nodes, it doesn't really make sense to talk about DMVPN, but for more nodes, it will make a lot. It will be a lot. It will make a lot of more sense. So I will create one DMVPN domain in order to communicate the orange virtual networks, and then I will need another DMVPN domain in order to communicate the red BNIDs. So I could select this as the hub and this is as the spoke, and then I will create a DMVPN domain in order to communicate these two virtual networks IDs. So this is how I can use my traditional wide area network and have a way to preserve macro segmentation when communicating two sites together. The same applies for IPsec. If I wanted to go for IPsec, I will create an IPsec tunnel for one BNID, another IPsec tunnel for another BNID. You can also use multi-protocol BGP. For instance, if you have several BNIDs, your red BNID and your orange BNID, and you had a green BNID, and you could talk with your MPLS provider. So in this case, your MPLS provider will establish a multi-protocol BGP session here to this router and a multi-protocol BGP session here to the other router in the other end. And the provider usually use MPLS within their network, and the provider usually provides you only one VRF to communicate two sites, but you can negotiate with the provider in order to let you have more VRFs. So in this case, the provider will configure for you within their MPLS network a red VRF and an orange VRF and a green VRF. So in that way, you could maintain your macro segmentation across your wide area network. That's it.